Ever tried mastering a new skill, only to realize you've forgotten an old one? That's the AI equivalent of catastrophic forgetting, a pesky problem where neural networks erase prior knowledge when learning new tasks. Think of it as a student who nails geometry, but then blanks on algebra. How do we stop AI from losing its mind? Let's dive into the science. Traditional approaches like Synaptic Intelligence, SI, attempt to preserve critical network parameters by tracking how much each weight changes during training. Imagine a student highlighting key formulas in a textbook to revisit later. But here's the catch: deep learning isn't linear. The lost landscape, the mathematical terrain where models optimize, has ridges, valleys, and hidden traps. SI's simplistic metric for importance often overprotects some parameters or misses others entirely, leading to suboptimal performance. Enter Plateau Phase Activity Profiling, PPAP, a breakthrough from Bar-Ilan University. Instead of monitoring every parameter throughout training, PPAP zeroes in on the final phase, when the model's performance plateaus. Picture a student who's hit a wall. Grades stop improving, but the brain is still processing. During this phase, parameters interact in a way that reveals which are rigid and which are malleable. Here's the twist: parameters that fluctuate during the plateau are like adaptive skills. They can be fine-tuned without destabilizing existing knowledge. PPAP quantifies this movement, assigning each parameter a flexibility score. When learning new tasks, the model prioritizes updating these flexible weights while keeping the rest stable, like a musician practicing new chords without messing up the old ones. Researchers tested PPAP on image recognition tasks, pitting it against SI. The results: PPAP not only minimized forgetting, but also excelled at balancing old and new knowledge. In one experiment, a model trained on diverse image categories retained 15% more accuracy when learning new tasks compared to SI. The key: focusing on the final training phase, where the model's muscle memory is most revealing. Why does this matter? Modern AI systems must adapt without erasing their past. A self-driving car can't forget how to stop at red lights while learning new routes. A chatbot can't lose its grasp of physics while mastering poetry. PPAP's targeted approach tackles the messy, non-convex nature of deep learning, offering a roadmap for stable, incremental growth. So the next time you're learning something new, remember, even AI has its own version of "I forgot how to do that." But with innovations like PPAP, researchers are building systems that don't just learn, they remember. Stay curious, and let's keep pushing the boundaries of what machines can understand.